Okay, so we're on class 20. We're going to talk about derivatives of trig functions today. And just to point out things that are coming up, your steel drum project is due on the 26th. That's Monday. And test 2 is coming up a week from Monday. A week from Monday, November 2nd. All right, so today we're going to discover formulas for the derivatives of trig functions and use them with other derivative rules to solve optimization problems. All right, so here I've got the graph of the sine of x. You should all recognize it from the day we reviewed our trig functions. So we don't yet have a way to differentiate the sine of x. We know that its derivative is cosine x because I've told you, but we're going to look sort of at a graphical reasoning of why. So I just want to try to sketch the graph of this thing, the graph of this function's derivative. So remember, when you're sketching a derivative function, you're sketching the slope of the tangent line. Okay, so I've got horizontal tangent lines at pi over 2 and 3 pi over 2. And horizontal tangent lines have what slope? 0. So I'm going to put zeros at pi over 2 and 3 pi over 2. And then if I draw a little tangent line right there, what does the slope of that line look like? 1. Okay, so I'm going to put, maybe I should do different colors for the derivatives and the tangent lines. Okay, so that looks like it's got a slope of 1, so I'm going to put a 1 right there. And then how about if I draw a tangent line right here, what slope does that look like? -1, approximately -1. And then I've got one more. If I were to continue this sine curve, I would have a tangent line right there that again looks like it has a slope of 1. So plot that one. And if I connect these, too high. If I connect my orange dots with a nice smooth curve, what function does that look like? It looks like the cosine function. Yeah. So based on our sketch, we can guess that the derivative of the sine of x is the cosine of x. We just sketched its derivative and recognized it because we're familiar with the 6 trig functions graphs. So then if I were to use the chain rule, right? So if I want to take the derivative of the sine of some stuff, that would be the cosine of some stuff times the derivative of the stuff. Okay. And then we'll do a similar argument to try to find the derivative of the cosine function. So where is the derivative of cosine equal to 0? Zero, pi, and 2 pi. I've got horizontal tangent lines at 0, pi, and 2 pi. Okay, so I'm going to put zeros for my derivative at those x values. Okay. All right, and then I'm going to look at a couple of other spots. Right here where it's like the steepest negatively, and right here where it's the steepest positively. Okay. Looking at this tangent line at pi over 2, what does its slope look like approximately? -1. So at pi over 2, I plot a -1. And then at 3 pi over 2, that little tangent line I drew looks like it has a slope of +1. So at 3 pi over 2, I plot 1 for the derivative. And then I'm going to connect these with a nice smooth curve. And what trig function does that look like? It's a negative sign. It looks like, yeah. So it starts at its midline, which means it's sine, right? But the typical sine usually starts at its midline and goes up and then down, right? So this is actually a reflection. We flipped the sine graph over the x-axis. So this is the opposite of the sine of x. So that means the derivative of the cosine of some stuff is the negative sign of some stuff times the derivative of the stuff, right? So if instead of just an x, you have like a bunch of stuff in there that you're taking the cosine of, when you take its derivative, it's the negative sign of all that stuff times the derivative of the stuff. Okay, so we've seen sort of a graphical reasoning behind why the formulas for the derivatives of sine and cosine are what they are. The very last activity in your activities today is to do a really rigorous algebraic proof using the definition. The limit as h goes to 0 of f of x plus h minus f of x all over h. But it walks you through it. But I think that the graphical gives you a good intuition of why it is, and you can work on the algebraic a little bit later on your own. Here are the derivatives of all 6 of the trig functions. So I just showed you a graphical reasoning behind those 2 formulas. Okay. Later in your activities, you're going to derive this one. Right? And I gave you a hint on how to do that. And all the other 3 of them can be derived the same way tangent is. Okay? So I'm not going to make you derive them all, but you can do them the same way you do tangent. And you do have to memorize these. You have to know them, memorize them tonight, rememorize them for the next 6 nights. It's a nice similarity in the 2 columns. It will help you remember it. Or write it down on your note sheet that you're going to bring to the test. You know, it's just as long as you have these readily available on paper or in your brain. Okay, so you're just going to do some practice using these. Some practice taking derivatives, and then you've got some optimization problems, and then some proofy kind of things.